Hello everyone, this is Dr. Vivek Laha and today we are going to discuss about marketing problems and their mathematical formulation. So let us start with a marketing problem. Suppose a businessman is opening a new restaurant and has budgeted rupees 800,000 for advertisement in the coming month. Suppose we have this McDonald's shops and they are trying to sell their pizza and we have to do this marketing. So he is considering four types of advertising. These advertising modes are 30-second television commercials, 30-second of radio commercials, half-page advertisement in a newspaper, and full-page advertisement in a weekly magazine which will appear four times during the coming month. Now you must have seen all these types of advertisement like sell up to 50% and like this coming soon, call now, opening soon, sell. So these are different modes of advertisement like television, radio, newspaper and weekly magazines. So the data, the owner wishes to reach families with income over rupees 50,000 and with income under rupees 50,000. So there are two categories of the target audience. So you must have seen one person is buying things in the supermarket and the other person is buying things in the local market. So you have two categories of these customers and we have to reach both the categories. Now, the amount of exposure of each media to families of type A and B and the cost of each media is shown below. So this is the media and you see cost of advertisement in rupees 50,000 category A. So this is television 40,000, radio 20,000, newspaper 15,000 and magazine 5,000. Whereas exposure to families with annual income over rupees 50,000 is B, and you can see this is 2 lakh and 5 lakh and 3 lakh and 1 lakh. So these are some other data associated with this. Now we have to have a balanced campaign. The owner has determined the following four restrictions. So what are the restrictions? There should be no more than 4 television advertisements. There should be no more than 4 advertisements in a magazine. There should be not be more than 60% of all advertisements in newspaper and magazine put together. And there must be at least 4,500,000 exposures to families with annual income of over rupees 50,000. Now we have to formulate this problem as an LP model, that is a linear programming model, to determine the number of each type of advertisement to be given so as to maximize the total number of exposures. So what is your choice? That is, we have to take decision on these variables and we will use the method of linear programming problem to find out the answer. So let us go step by step. So the step 1 is to identify the decision variables and let us reconsider this problem in fragments. So what we have to do, we have to formulate this problem as an LP model to determine. See what we have to do. We have to determine. See, to determine the number of each type of advertisement to be given. So this is the decision variable on which we have to take the decisions. So we decide that if for a television we will take x1 number of advertisements, for radio we will have x2 number of advertisements, for newspaper we will have x3 number of advertisements, and in a magazine we will have x4 number of advertisements. Now the step 2 is to identify the constants. So a businessman is opening a new restaurant and has budgeted rupees 800,000 for advertisement in the coming month. So see, this data rupees 800,000 must be used, and this is a type of budget constant. We call it C1. And how we can formulate this? See, it is given that cost of each advertisement in television is rupees 40,000, in radio it is 20,000, in newspaper it is 15,000, and in a magazine it is 5,000. And the number of advertisements, we have assumed it will be x1, x2, x3 and x4. So the total cost for advertisement in television will be 40,000 x1, for radio it will be 20,000 x2, for newspaper it will be 15,000 x3, and for a magazine it will be 5,000 x4. So the total cost of advertisement in all these four media will be given like this, and this can be written as a constant, and that will be C1, which is 40,000 x1 plus 20,000 x2 plus 15,000 x3 plus 5,000 x4. But it should not be more than 800,000. So it should be less than equal to 800,000. So we have this first constant with us. Now the other thing, there should be no more than 4 television advertisements. So this number of television advertisements must be x1, and that is less than equal to 4. There should be no more than 4 advertisements in the magazine. So the number of advertisements in the magazine is x4, and it should be less than equal to 4. Now, there should not be more than 60% of all advertisements in newspaper and magazine put together. So this 60%, and see, the total number of advertisements is x1 plus x2 plus x3 plus x4, and the number of advertisements in newspaper and magazine put together is x3 and x4. So this x3 and x4 must not be more than, that is, it should be less than or equal to 60% of x1 plus x2 plus x3 plus x4. So you can do a simple calculation, and it will show, it will give you the fourth constant, that is minus 6x1 minus 6x2 plus 4x3 plus 4x4 must be less than equal to 0. You see, this 60% will be 6 by 100, 6 by 10, and that will be 3 by 5. So now the next constant will be, there must be at least 4,500,000 exposures to families with annual income of over rupees 50,000. So if the annual, see, at least 4,500,000 exposures, and this annual income should be over rupees 50,000. So this data is with us, number of exposures per advertisement to families with income more than rupees 50,000. So for one advertisement, the exposure, one advertisement in television, the exposure will be 200,000 families. So for X1 number of advertisements, it will have 200,000 X1. Similarly, in radio, the exposure will be 500,000 X2, and in newspaper it will be 300,000 X3, and in magazine it will be 100,000 X4. So total number of exposures will be given like this, but it should be at least 4,500,000. So what we are taking, the C5 must be greater than or equal to 4,500,000. See this number. Now what we are going to do, we will take the other constant, that is number of ads can neither be negative nor be fractional. So what we are doing, it should be either it will be 0 or 1 or 2 or 3 or 4 like that. It cannot be fractional. It should not be equal to 2 by 3 or 3 by 4, etc. So it cannot be in the form of P by Q, where this P and Q are integers, and Q is not equal to 0, something like that. So what we are having is, the next thing is this x1, x2, x3 and x4 must be greater than equal to 0 and must be integers. So now we have this the last thing is to identify the objective. So what is the objective? See, formulate this problem as an LP model to determine the number of each type of advertisement to be given so as to maximize the total number of exposure. So what we have to do, we have to maximize the total number of exposures. And this is the exposure. See, number of exposures per ad to families with income more than rupees 50,000 and number of exposures per ad to families with income less than rupees 50,000. So we have this in television. If you have 200,000 see exposures in one ad, then for X1 it will be 200,000 X1, and for families with income less than rupees 50,000 it will be 300,000 X1. So you add both these things, this will be 200 plus 200,000 plus 300,000, and you multiply it with X1, so it will be 500,000 X1. Similarly, we can take these for radio, and it will be uh, C. And all these numbers, you just add these two columns and multiply with this third column. So this is the total number of exposures with families, and these exposures can be, but this we have to maximize. So this can be written as an objective function. So we assume that this to be the objective function, number of exposures z, and that is a function of x1, x2, x3 and x4, and we have to maximize this objective function. Now if you just take all these things together, we have to maximize this objective function. Then we have this constant c1, then we have this constant c2, and we have this constant c4, x4 less than equal to 4, and this is c4 minus 6x1 minus 6x2 plus 4x3 plus 4x4 less than equal to 0, and we have this fifth constant at 200 x1 plus 500,000 x2 plus 300,000 x3 plus 100,000 x4 is less than equal to 4,500,000, and we have this last constant as non-negativity constants and integer constants. So this is known as linear programming problem, since all the objective functions and all the constants are linear functions. See, these are linear functions of x1, x2, x3 and x4, and therefore it is a linear programming problem, and since integer constants are also involved in this, so it is a linear integer programming problem. Now what we have done till now, we have a marketing problem, and we have identified the decision variables, and then we have identified the constants, and then we have identified the objective function, and then we saw that we have an integer programming problem. As in the previous case as well, the question is how to solve this integer programming problem. So we can use different types of methods which we will discuss in the upcoming lectures. Okay. Thank you for joining.